sorry.
It's fun. Except for having her take the.
I guess I chose to be here as no rush.
What's up, fellas?
Couple floors of science.
That's fair. It's a very mean joke.
That took me a minute. I got it.
My usual answer is gas prices.
Especially right now.
And it's a lot more.
Here's the
Last
truth, not
weekend it was under $2.
That didn't last long. I found one station this weekend that was under $2, but the pump literally wouldn't sell me gas. It didn't say empty, it just didn't work.
What's the cheapest gas price you've ever seen?
Ever?
No.
I don't know. Probably would have been when I was a kid, but I wasn't paying attention at the time.
I saw 135 last year.
Where?
So it was either right near the North Carolina, South Carolina border or right near the North Carolina, Virginia border. 135.
Okay.
So expensive.
You're just hoping for-
Remember when it was up to like $4?
Yes.
Yes.
That wasn't fun.
When
I
I was
remember-
learning how to drive them.
One time in high school, I filled up my car for $13 because gas was like $1.13 or something. Like something stupid low. I don't have to go.
I drove a hybrid though,
No,
so it's
it's
not
not.
too expensive. I get, actually, I don't drive hybrid anymore. I used to, I couldn't. But I did get
Glad you're still here.
42 miles to the gallon, now I get 35, which is still good, but not as good as 42.
I'm gonna get no idea what I get for the gallon.
My dad gets 13,
So I could do the math really.
a Hummer is like 6.
I'm just making brief tweak to something up here so that I'm typing something out so I don't have to handwrite it at the moment. Because if I did handwrite it, no one would be able to read it.
I have a question.
Yes.
Are you going to change it so that when you get it wrong, it doesn't take all the points off on the homework, or are we just going to leave it like that?
My original intent was the first 5 attempts don't reduce your score. And then slowly happens over the next 30.
It says on the thing that it's your third score, you start losing points.
Really?
Mine started on the first one. Like if I
Mine
put in
was the third.
put it in twice, then I still got points on it.
Well, I didn't really know.
Oh, me neither.
So good job, you guys. We're really proud.
Clearly there are still some things I need to tweak.
I did open it. Hold the website up.
It is my grandpa had, I got it out in a secret. Actually, she wants to run a full trail.
One time I got a Google in
Do you have library?
Made up place from the 90s.
Oh, yes, I do.
They like that, but then they go like.
Okay.
Yeah. But it was like.
So I tweaked. Any other questions before we get started today?
What's your favorite snack?
Depends, like, the first thing my brain jumped to was fudge rounds at the moment. That's,
Then go with it. It's your gut response.
yeah, fudge rounds or yogurt.
Pretty big change.
Huh?
Those are two very different things.
Yeah.
They are. Yogurt's usually when I want a fudge round, but I don't think I should be one because it's not the time. said, sometimes you just want chocolate, and that's fine.
I probably eat 10 Starburst since I got that. Yeah.
Well, why would you get a bag of Starburst if you didn't want Starburst?
No, I like them. They're very good. But babies don't eat all of them.
That's what they're there for. All right, so we're into chapter 11, talking about various things involving movement of thermal energy. Oh no, why is it gone? Who erased it? Did I erase it? I didn't erase it.
Dr. Rhoda frozen.
Ah, okay, that explains it. Darn. Because I left something up here so that I didn't have to rewrite it. Oh well. So, I'm pulling up calendar so we can talk about a couple of things. First, the chapter 10 assignments, plural, is currently due for midnight, Tuesday the 9th. Come to class on that day, ask any questions you have. We'll finish up and we can review things then. And then we'll do that night, same with the quiz. So keep working going on those. After that, we're going to be moving towards one assignment per week. So the chapter 11 assignments are currently due for the 16th. And the chapter 12 assignments will be due on the 3rd, which means I might have to readjust something. I'm going to tell you in a second, but we should be fine. Now, that something is, I've decided on the preliminary test dates. These will shift if needed, and I will only ever shift them back. I will never give you a test earlier than advertised. Test 1 is going to be on everything heat and thermo related. It'll be chapters 10 through 12, and that will be tentatively on February 23rd. And my current plan for test format is to be administered through WebAssign. And on that day, on the 23rd, the test will be available to be taken. And like when the homework goes live, you can sign and do it whenever you want. Although it'll be closer to a quiz in that once you start it, the countdown begins. And from when you first open the assignment, you'll have 5 hours to complete it. It is only designed to take you 1 hour, like a normal test, but the extra time is for academic accommodation and because it takes you longer to get your questions answered via email and bathroom and dinner, etc. It'll go live on the 23rd, and you can take it at any time between when it goes up and before class on the 25th. So any 5-hour period from class here to class here, you can take it. Yes?
So it's going to start after class on the 23rd?
Yes.
And it's chapters 10 through 12?
Correct. And specifically, it's going to be everything about all of the 3 heat and thermo chapters. So everything we've done since the beginning. And after chapter 12, after this test, we'll be moving on from heat and thermo. Your answers will be submitted through WebAssign. It won't show you your grade immediately because it's not going to be correct because it hasn't accounted for partial credit. So after you're done, email me pictures of your work, either photocopy scans or even just a camera photo as long as it's legible. Make sure everything's numbered so that I know what work goes with what question, and I will adjust the grade and email you back your final score and then feedback per question. Yes?
So is it like how in physics when you could get all the questions wrong, you still get a 3?
Yes. Absolutely. You could probably get an A and not get any of the final numbers right if you did all the work perfectly. and then just did the last calculator step wrong. The work is worth most of your points, so yes, you can still pass and get nothing technically right.
So you could get a 0 in web design, but then get a good
Which is why I'm going to set it so WebAssign doesn't show you any grade so that you don't panic.
Okay, because I would panic.
I know, I don't want that for you guys. So, starting this day and before the next class period, you can start it whenever you want. I just recommend you do it during normal daylight hours because I'll be awake to answer your questions. Because if you started at 2 a.m. and I'm asleep, I'm not going to be able to answer your questions until the timer's done. So that's the first test. Second test is going to be on the 4 to 5 electricity and magnetism chapters. The test itself won't be any longer, even though there will be more chapters worth of topics on it. That date is tentatively April 6th. There might be a bit of a gap between test 1 and test 2, but that's because I really don't want to make a test that has both on it. I'd rather try to keep things separate until they have to mix for the exam. So test 2 will be only on the electricity and magnetism topics that we cover, nice and self-contained. And then after test 2, added to the exam, is any extra electricity and magnetism stuff we cover, plus waves. These dates are malleable, and then if something takes longer than I was expecting, I will push them back, but I will never push them up. So, do keep these in mind. I think the online nature should prevent most scheduling conflicts, but if you do still have one, please let me know. Yes?
What chapter is your test 2?
Good question. Which chapter number? I think it's 15. Yes. So this will be chapter 10 through 12. This will be about chapters 15 through 20, which is more topics, but it won't be more questions. To make sure of that. Doing it this way to keep the units contained with their counterparts. So, keep those in mind. I will be reminding you as these days come up. I will make sure that it's not a surprise for anyone. Emails just start coming, they won't stop coming. Any questions about those?
Is our final exam scheduled?
That date, yes. The academic calendar has that on it. I just forget when it is. Glad Google knows what I was asking for, even though I can't spell correctly. Okay. Spring semester. Exam, okay, so this is just the exam days. I don't off the top of my head know which day our exam is, but that's going to be, the exam season is May 7th through 10th.
May 10th?
Yes. Oh, wait. Well, okay, through the 12th, actually, but not everyone's going to have exams every single day, or particular document I'm looking at is not very helpful. Final exams. Spring exams. This is H period, correct?
Yes.
So that means this particular exam, oh, that's delightful.
What?
On Sunday, Mother's Day.
That's Mother's Day? Is it?
Yeah.
May 12th? Or
Ooh.
no, May 9th? Nice.
Okay, so I hate that at least as much as you guys. Thankfully, the E period takes the same exam, and I don't care which session you attend.
Except for senior grades, I think are already due by then.
Oops. Sorry about that.
It's okay. Sorry, Mom.
Well, I was planning on doing the exam over website anyways, so you can at least be at Mom's place.
I wasn't home for Mother's Day last year. I just won't be home for Mother's Day
What
this
classes
year.
are having
Oops.
I have it.
Well,
I was
I definitely
quarantined.
didn't this.
No, I know,
Sorry.
taking that on a Sunday. That would,
Last semester I had one Sunday night, so I had to rush over here.
Terrible.
No, I checked.
oh wait, no.
So wait, you said you're gonna do it on
Oh,
website?
that's online. Oh my gosh, I could leave by Sunday. It's really frustrating.
Just paint it with a clear nail polish.
The semester's already over. Why do that?
It's not fun if we're not unhappy.
You should just make it our last class. Is that allowed?
All in
I
favor,
was
please say
planning on
aye.
doing it over website anyway, so I'll see what I'm allowed to do within that range of flexibility.
I would do it at home except for too many facilities.
Well, I have to plan on it being at least remote optional because some people, especially at the end of the semester, go some places and they can't come back.
When is the last day of class?
Last day of class is, oh, that's last. Wednesday, May 5th.
Where would people be going that they couldn't come back?
Well, last semester I had some international students, but I also had like 50 students last semester. So a lot fewer than this time. Which means
Reading day.
we should be
Yeah,
able.
you should just do it on reading day.
Reading day?
Reading day is Thursday, May 6th.
Nothing is sacred at Presbyterian College. You can do what you want.
That's true. Last semester, we didn't even have reading day.
I went hiking on reading day last year. Oh, no, 2 years ago.
No one does everybody does everything but read on reading day.
I
For the most
literally
part.
I'm aware.
like Table Rock.
I was a student. My reading days usually consisted of eating, sleeping, and video games. And they
It's
still
like
do.
nap day for the dark day.
Okay, we have time for me to see what I'm allowed to do there. I will do my best to make that as easy as possible. So, in terms of actual physics, we're going to continue on with chapter 11, beginning with calorimetry. As a reminder, we left off on everyone's old friend, specific heat. Before we get to any other questions besides the exam nonsense, why did they put it on Sunday? Okay. So, you should be familiar with the concept that energy cannot be created or destroyed. It simply moves or changes state. And if one object is going to gain some amount of thermal energy, some other object had to lose the same amount. Summarized here, Q lost by one object equals Q gained. Off the top of your heads, what do the brackets on either side of the Q's mean?
Absolute value.
Very good. That's just because since one object is losing heat, that's naturally going to make it a negative number. Meanwhile, on the other side, something will gain the same amount of heat, but in the positive direction. And we don't want a positive to be equal to a negative, so we put those brackets on there to just get rid of that little quandary.
What's the specific heat of copper?
Very good question. So, in our sample question, we are looking at copper and water. Backtrack real quick to our little table on the previous slide. Water is same as it always was. Copper is 387. Both of those specific heats. We are dropping 50-gram piece of copper. So mass CU is 50 grams. We prefer kilograms around here. So how many kg is that?
0.05.
Very good. Now, we are told the volume of water. What does that mean for the mass of water?
1 kilogram?
Yep. Density of water is 1 kilogram per liter. We know additionally, temperature initial copper is 120 Celsius. Temperature initial water is 21 Celsius. And what we were asked to find is the total final temperature for both objects. Because when two objects are touching for any length of time, thermal energy transfers from one to the other in an attempt to reach thermal equilibrium, which just means they want to be at the same temperature. Once they are at the same temperature, the energy flow stops, and there's no need to trade anymore because everything's equalized. So, we have one TF and a bunch of other variables. Let's set this up. One object is losing, that's going to be the water. An object is gaining. Oh, sorry. Losing is the copper, excuse me. Gaining is the water. I tend to prefer writing the formula like this because Q lost is always going to be a negative number because the temperature is going down. The negative out front of that gets rid of the negative, so it equals the positive over here. That's how I prefer to do it because it's a specific operator that I can very quickly do instead of the absolute value. Any issues with that? Does anyone object to this?
No.
Okay. So, negative Q lost, we're looking at the copper. This formula is going to require us to use MC delta T in here. So, for the copper, we want the mass of the copper. Well, that's just the heat of copper times delta T for copper, which is always final minus initial, equals, same info for water,
Shouldn't it be .05?
It should be, thank you. Now, it's the same TF because they're both trying to reach thermal equilibrium. This is sort of the trickiest version of this type of problem where you are solving for the one combined final temperature. Just because you have to fish the TFs out and then combine them on one side. So we have everything in place. It's now just time to begin the algebra parade. This desk is now my chair. So, my recommendation is distribute these distribute the M and the C into the parentheses, then we can start manipulating the TFs. Negative 0.05 times 387 times TF. This is negative being multiplied by a negative, so now we have plus 120, 0.05, 387. So that's the left side. Right side, I'm going to go ahead and just factor, we're multiplying by 1, so I'm just going to get rid of a 1. 4186 TF minus 21 times 4186. You're welcome to start multiplying terms into each other to simplify. Why do my 4s look like 9s? We want both TFs on one side, and then we want that side to only have TFs. So, my recommendation there is, you have a negative TF term on the left and a positive TF term on the right. My thought is to send the one on the left over so that it becomes positive. That just gets rid of the one negative, so we don't have to deal with it. At this point, everything on the left is just numbers. That can be simplified. I'm keeping it as is just to show every step. On the right, though, we can distribute the TFs out. Simplify a tiny bit. How are we doing so far?
Which y'all get? 21. Yeah, 21.655.
I got 21.46.
So the consensus is everyone's answer is very close to 21, which is to say that the water barely heated up, correct?
Correct.
Which is correct. So when you divide it over and solve TF equals blank, yes, it's going to be about just barely 22 Celsius. And that's because entirely of the specific heat of water simply overpowering the specific heat of the copper. Water just eats heats all of the thermal energy and then just has it and doesn't change temperature, or like, and this is why we use water to cool everything off, because blacksmiths have been dunking red hot steel into water for a very long time.
I
Just
like
takes-
simplified mine first, just, I didn't leave them all in parentheses, so it could have been, I just plugged something in.
Wait, can you explain what the higher and the
I thought I
lower
did that too, and I
specific
said
heat
21.4.
Right.
Which one is high, which one is low?
So, water's specific heat is over 10 times bigger than copper's, which means that water needs more thermal energy to warm up. The more thermal energy it needs, the harder it is to change its temperature. So you need to dump a lot of thermal energy into water to
So
warm it.
does that number mean that it would take 400 or 4,000 blah 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 joules to heat up a kilogram of water at degree Celsius?
Correct. Which is why a wash pot never boils. Again, it's a pain if you are intentionally trying to warm the water up, but if water didn't do this, life on this planet wouldn't be possible. Meanwhile, copper, pretty low specific heat, all things considered. It does not take a lot of thermal energy to warm copper, although comparatively speaking, the lowest specific heat on this table is actually lead, which means it is not only poisonous, but it can't even maintain its own heat, so it's just triply useless. Sorry, it's poisonous, it isn't malleable, and also doesn't maintain its own heat, so useless.
It's a big, we used to paint our walls with that.
Say again?
We used to put that paint
I think it's because it made the colors nicer.
and toxic to toddlers.
Yes.
Should you
Why
really
would
be
you
letting
make
your
the wall?
toddler eat paint though?
Because
It's
they're
not that they
cute.
were eating it, it's just that kids will touch walls and then touch their faces.
Didn't they used to put lead in like makeup?
I don't know about makeup, I know it used to be in gasoline.
I think in like
That's-
European makeup they used to put lead in.
That's terrible.
I think it was like, what I read was that, because you know they really wanted to be pale, because it was like fancy and like posh to be pale, so they would put lead on their face, and then their face would get red and break out, so they put more white lead, and then it was like a vicious cycle, they just kept putting lead on their face.
Girl. I had not heard about that, but I believe it completely. I assume then that lead rusts white to make that happen. Anyway, so yes, high specific heat resists temperature change. It also means that it'll stay hot longer. So it's a pain to make your water boil, but it'll stay warm afterwards. Did everyone manage to guess to that final answer of just a little more than 21
I have a
Celsius?
question. So would the best thing to like cool hot water down be like cold water?
Best thing would be ice.
I guess that is cold water.
It is water, you're right, but ice has the benefit of going through a phase change to absorb more of that thermal energy. It'll still take a little while, because very rarely do you throw ice into boiling water and it immediately melt, but that's one of the fastest things. Actually, we're about to get into phase change, so I'm glad you asked. So, any questions about calorimetry? This is just this applied to two objects at once. I assume it's things you've probably seen before as well. Okay. And again, the version where you're finding the one final temperature for two separate things is probably the longest and most irritating version. So, I want to make sure one of those wound up in your notes. We'll refer back to it later as well. But, thank you for segueing us nicely into phase change. I thank you for that. In order to change something's temperature, you have to change how much thermal energy it has. But things get a little weird around when you are changing something's temperature through a phase change. by which I mean changing the state of matter, melting, evaporating, etc. Now, this first thing is to address kind of something that makes sense when you think about it, but does make you do a double take at first. Melting is a cooling process, freezing is a warming process, condensing, which is gas to liquid, is a warming process, and boiling is a cooling process. At first glance, does that sound wrong? Good, because that's completely logical. I thought so myself. However, these statements are from the perspective of the surroundings, not of the object interacting with this phase change. To induce a phase change, you either have to remove thermal energy to, say, freeze something, or add thermal energy to, say, melt it. And because of our conservation of energy calorimetry, we know that that energy had to come from somewhere or is going somewhere. So if you are melting an object, that object needs to absorb thermal energy to get warmer and then melt, which means that the thermal energy that's now in it is not in its surroundings, which is why putting ice in your water cools the water down. The ice begins melting by absorbing thermal energy from the water, cooling the water off. And meanwhile, if you are freezing water, if you put something in your freezer, the freezer has to remove thermal energy from the new object to get it to freezing temperatures, which makes the rest of the freezer warmer. So all these statements are from the perspective of the things around the reaction, not necessarily the object itself. Excuse me. And this is important to think about for phase change because you have to keep in mind the direction of the energy flow. So again, these are from the environment's perspective. Endothermic processes absorb heat from the environment. That would in this case include melting and boiling. Exothermic give heat off, which in this case would be freezing and condensing. Actually, this statement right here, this boiling is a cooling process, is the entire reason why humans sweat, which you probably heard before. But when you sweat, there's now water on your skin. The water wants to evaporate, and it absorbs thermal energy from you in order to do it.
But can you explain which one is endothermic?
Yes, endothermic means it is absorbing heat from the environment. So an endothermic process cools down the surroundings, which would make evaporating, boiling a cooling process from the surroundings perspective, as well as melting. Melting ice in your water will cool the water off, and sweat evaporating off of your skin cools you down. So endothermic cools down the surroundings but warms up the object. Meanwhile, exothermic heats up the surroundings and cools off the object. Just from endo meaning in, exo meaning out. There's also a third term, isothermic, where thermal energy level just doesn't change. But I don't think we're going to be working an example for that in this particular section. So, when one changes phase, you have to absorb or give off an amount of thermal energy to make that happen. The math for that is summarized here. Q is still thermal energy needed to, Q is still heat. It's still thermal energy needed to add or be added to or removed from something to make this process happen. To figure out how much thermal energy you need to melt or to remove to freeze something, you need to know the mass of what object you're trying to induce the phase change in, and you need to know a constant relating to what that object is made of. This whole section, actually no, this whole semester is just a bunch of constants. Just constant table after constant table. Which again means you never have to remember any of them. You'll have the tables. But every single process has a different, every different material has a different constant referring to how much it specifically needs in order to change specific phases. And uniquely, per substance, there's actually 2 of these constants. The latent heat of fusion is for any change between solid and liquid. So the same constant would be used for water melting and water freezing. Meanwhile, the latent heat of vaporization is the constant for any change going from liquid to gas or gas to liquid. So, again, you do not have to remember any of these. Just be able to scan through the table. Oh, I forgot this is a long period.
If you want to make it a short period, that's okay.
Well,
I want you to feel like you have options.
I do appreciate having options. I could actually use a quick break to rest my main pipes, maybe get some more water. So I'm going to call that here. We're just going to take a quick break before we look at the ever popular phase change versus temperature table. So I'm going to fill this up and be right back.
Lainey, what time did we leave lab yesterday? 2 days ago.
And I think we also, he didn't have everything set up when we went in there, so we didn't start until later.
Okay. You could probably be out by 2:30, 2:45.
What is that?
You're heating up metal pipes with smelly vapor.
Fun, okay.
My lab had 2 people in it. Me and Emily the women.
In today's lab, I only have 3. That's just how the signups went. As a reminder, you can switch sections if you ever need to, although I wouldn't recommend people switching into the Tuesday one.
Well, the one of my friends literally thinks that Wyoming is not the state.
I mean,
She's like, her reasoning is Wyoming is not a real state. You cannot tell me it is a real state because you cannot have more electoral votes than you do escalators.
But
that's fair. But even if
How
Wyoming
many
is not a
escalators
state,
are in
something has to
Wyoming?
exist there.
is there only 2 malls in Wyoming?
There's nothing in Wyoming.
That's true. It is the least populous state.
I have heard that. I have heard
I thought Alaska was the least.
that. Now Alaska's biggest by land mass, so that by itself means it has to have an amount of people in it.
I think it's the least per
It might be like
space.
Yeah, but looking at just the number of people that interstate white places.
Yeah.
Hold on, I'm looking.
What's your jobs in Wyoming? You go work on a dude ranch? That's pretty much all that's out there.
I don't know, forest ranger, just the whole state.
Yes.
All right. As of 2019, there were 578,759 people living in Wyoming.
Oh my gosh, that's.
Say that number
so
again.
low.
578,759.
Okay.
So,
That means there are singular cities that are larger than the.
A lot of cities that are larger.
Alaska, Alaska beat them. In 2019, they had 731,545.
I just
Rhode
looked it up,
Island.
and when you Google Alaska population, it draws a direct comparison to Wyoming's population.
What
Well,
is
the
Rhode
next
Island?
comparison is Hawaii at 1.4 million.
Those are my people.
I feel like Rhode Island should be low because it's so small.
Yeah, but they have a lot of people per square mile.
I know, but it's also so small.
Let's look it up. 1.1
1,500,000.
Still small.
Yeah, per square foot, I think Rhode Island might have Hawaii.
People ask on Google, is Rhode Island ghetto? That is the first question.
I like when celebrities read those things where they're like,
They're like the
is
most
Ryan
stable.
Reynolds
Yeah.
blank? And they like peel off the, like one of them was like, is Ryan Reynolds ugly? And he was like, are you kidding me? First of all, why would you even look that up?
Someone watched Deadpool and thought that was his real face.
Probably.
But also, like, who Googles entire, like, questions like that? Just,
People looking for autofill walls.
Yeah, for your friendship bracelet.
you have to have friends in order to do that.
No.
Oof.
It's true.
Meaning. Whoops.
According to this, Rhode Island is one of the safest states in America.
So it's not ghetto.
This is
It's so small, there's no space for crime to happen.
according to alarms.org.
What's the most dangerous state?
Let's find out.
Just in terms of crimes committed, it would probably be one of the more populated ones.
Illinois.
So my first thing, yes, would be.
Yeah, I know, I'm just
State of
Chicago.
California.
Chicago as a state.
Oh, right, I forgot.
Dangerous.
Mississippi?
That's not what I was expecting.
Most dangerous states 2021 World Population Review. Let's talk about it. Okay,
Shall we?
shall we?
Question mark?
Most dangerous states. Hold on, I'm reading, according to the Global Peace Index, the United States is the 128th safest country in the world out of 163.
Good job, guys.
Not the best.
Right.
We're terrible.
That makes me
So-
think Clemson Pie Cap posted on their like, page and it was like, congratulations, we came 32nd in grades. And I was like, oh, and I stood up, I said, how many groups are there? And they said, 46. I said, oh, good job. I'm so glad that you're promoting that. Anyway.
How do we determine the safest and most dangerous states in the U.S.? Giving a total score out of 100, the indicators are grouped into the following categories: personal and residential safety, financial safety, road safety, workplace safety, and emergency preparedness. This is a little bit more
That's
in-depth.
why Mississippi's the bottom.
Yeah.
Not
No
prepared
road
for
safety and no
emergencies.
emergency preparedness.
You're a little underdeveloped.
Sorry,
Georgia,
I'm conflating Mississippi with Missouri right now.
very different.
Well, I've heard mostly only bad things about Missouri, unless you really like arches. Okay.
This one says New Mexico. What?
New Mexico?
I don't know what's going on.
It looks like everyone has their own definition of danger.
It's
Look up what state you're most likely to be murdered.
dangerous states, which states have the highest rates of violent crime in most
Yeah,
years.
that's what I was wondering.
This is according to USA Today. Well, 50 is Maine. Good job, Maine.
Huh. Well, you know what it is, half of them are Canadian.
Hold on, I'm still trying to find them. Number 1, Alaska.
Alaska's dangerous, is that what I mean?
Because
violent-
ice road trucking is dangerous, and that's what half of them do.
Violent crime rate is
Ice road trucking and
885
lobster
per
fishing.
100,000.
Okay,
You know what, we're definitely learning something today.
something.
Anchorage.
Crime statistics isn't on the syllabus, and yet. Okay.
New Mexico is number 2, so I think that New Mexico is legitimately a problem.
I passed through there. It's very pretty country, though.
What?
It's a very pretty part of the country.
Also, South Carolina is number 9.
Oh, good job, guys.
Good night.
St. George Boston.
Most dangerous city, Greenwood.
What was number 1?
Number 1 was Alaska, and the most dangerous city was Anchorage.
Well, 4 years ago, North Charleston had the highest murder per capita of any city in America. Because there's not a lot of people in North Charleston, but there's a lot of murders.
That's cute.
That's terrifying.
That's like 20 minutes from my house.
Oh, great.
You know what the problem is? That would mean there's a lot of ghosts in North Charleston, and that's just going to add the problem.
There was a shooting at the mall 2 weeks ago.
Okay. I'm going to try to segue us back to physics now. So, phase change. Who hasn't seen this graph before? So, does that mean everyone has seen this graph before?
Yes.
Very good. So, brief refresher. In order to change something's phase, then, you just have to go through every single step of this chart for as long as the experiment lasts. So to go from ice to steam, you have to warm the ice up to melting. Melting is just the point where the ice and water can coexist. Then you have to undergo the phase change itself using the latent heat formulas. So here, you use latent heat diffusion with the mass of the ice to figure out how much thermal energy needs to be added to melt it. Once it's entirely melted, you can add more thermal energy to warm it up to the point where it would begin evaporating. At that point, you use latent heat of vaporization to figure out how much heat is needed to evaporate that mass of water into steam. Once it's steam, adding more thermal energy will continue to increase its temperature. Main takeaways to remember here are A, you have to go through each individual step one at a time, and B, the temperature only changes once the phase change is done. So if the water itself is already boiling, the water can't be made hotter than 100 Celsius until it is steamed. Which is why once it hits boiling, it just stays there until it's gone. The only thing you can do to change its temperature is change what it is by adding like salt or something. Yes?
So is there a difference, like when you're cooking, you can have like a rolling boil where it has like very large bubbles, where you can have like just boiling where they're very small bubbles, but it is still boiling?
I suppose that would just be a function of how much thermal energy is being added to it per second. Because the faster you dump thermal energy in, the faster it would turn into steam. So a more vigorous boil would be more thermal energy per second, whereas only just barely boiling would mean the water is 100 Celsius and that's it.
We also proved in pre-chem last semester that because you have to add so much salt to your pasta water, that it doesn't actually elevate your boiling.
Should I say again?
Like when you add salt to pasta water, that's like something people do because it changes the boiling temperature of the water,
Right.
which is like kind of false because you would have to add an insane amount of salt for it to actually change.
Correct.
Like we wrote that on our map.
Well, additionally, that just makes the boiling temperature slightly higher, but that means it's going to take longer to get there.
Like, doesn't really do anything. It's essentially the takeaway.
Right. Except increase the sodium level in your food, which is why I stopped doing it. Because high blood pressure runs in the family. Okay, so probably the last question we'll look at today. We are going to combine calorimetry and phase change together to figure out how much ice needs to be added. Sorry, no. Yeah, we're going to phase change two different sides. I forgot my notes. Yes, we are. So, this is combo calorimetry and phase change. So we're going to be looking at two sides at once. And I'm going to roll this up to right on the board under it. So, just to paint the picture of the before and after. We have a box full of steam, and we put solid ice in the box with the steam. This is our before. Steam is at 115 Celsius. Ice is at -6 Celsius. After, it's all 45 degrees Celsius water. So, the steam is going to condense into water, the ice is going to melt into water. Our two objects are the steam and the ice. So, one will be the object losing thermal energy, the other will be the object gaining thermal energy. This marker is running out of ink. I found leaving them upside down overnight resuscitates them for the next day, at least for a little while. So, the steam is going to be what is losing thermal energy, and we have to take it through every single step of its phase change. So what's the first thing one must do to begin turning steam into water?
Cool it down.
All right, we're going to cool it down. I'm going to do negative open parentheses, and then all of our steps for this side, just to start with. So first, we cool down the steam, so that's going to be MC delta T. That's going to be, I'm going to use S for steam, just to shorten it. So mass of steam, heat of steam, delta T for steam. Then, after we cool it down to the condensation point, it has to actually condense. So we're going to add on to that this using latent heat of vaporization of steam. Then, once it is liquid water, we have to cool it down to its final temperature. I'm just going to go ahead and write in that temperature change. So I'm running out of variables.
Do we write in the temperature change for the other one?
Yeah, we can go ahead and do that. So the steam has to cool from 115 to 100. Actually, I'm going to put a bracket on the front because I'm using too many parentheses already. Then, on the water side, sorry, the ice side, First thing it has to do to turn into water is warm itself up. So very similarly, mass of ice, specific heat of ice, delta T, we're going 2.6 from 0. Plus, the ice has to melt, so that's mass of ice times the latent heat of fusion for ice. Then, the ice will warm from 0 to 45. So good old-fashioned sort of step problem there.
So we have to plug in all of these variables that we don't know.
Well, let's list them to figure out what we do know and what we need to look up. And let's also figure out, okay, the thing we're eventually asked for is grams of ice. So the thing that we want out of this is mass of ice. That's our end goal. We do know mass of steam. Good luck measuring the mass of steam, but there we go. We know temperature initial for both objects. And the temperature final of both objects. So we don't specifically have the constants for all these things in place yet, but we have tables where we can look at them. We want specific heat of steam, specific heat of water, specific heat of ice, latent heat of fusion for steam, latent heat of vaporization for, the latent heat of fusion and vaporization for H2O. So that's 5 constants we're going to look up. Joyous. But we have our tables, eventually. There they are. Oops. Hey, look at that. Miraculously, it's just low enough to see water. Okay. Latent heat of fusion that we care about for H2O is 3.33 times 10 to the 5th power?
Yes.
Yes, it is. Latent heat of vaporization. 2.26 times 10 to the 6th. Then specific heats. I remember waters off the top of my head. I don't remember the other two. Steam at 2010, the year I finished high school. And ice at 2090. Interesting, it changes so much at different phases for the same material. I will be 98 that year. My goal to make it to 100, so 2092. start plugging them in, I think we should go ahead and pull mass ice out. 'Cause that's what we want. Let's just go ahead and distribute it out so we have it on this side. Does that sound fair?
Sure.
Okay. And now we don't have to separate it after the fact.
Would it be easier though to plug everything in and move around numbers instead of letters?
Well, my plan looking at this is, go ahead and pull the MI out. Now we plug in the numbers. And we have numbers for everything except MI. So after we put the numbers in, everything's just going to start condensing down. This is already separated, we don't have to deal with it later. Anyone have any objections to that step? Okay. So, still going to keep the negative out front for now. Mass of the steam is 0.1. Specific heat of steam, 0.10. 115 minus 100, 15. Plus 0.1. Latent heat of vaporization for steam is 2.26 times 10 to the 6th. Plus mass of steam times specific heat of water. 45 minus 100 is going to give us a negative 55. Equal to, open bracket, C of ice is 2090 times negative 6. No, I made a mistake. I put 0 minus 6. It should be 0 minus negative 6. It should be positive 6. That one's on me. I apologize. Because it's going up in temperature, that should be a positive number. Plus 3.33 times 10 to the 5th, latent heat of fusion for ice, plus specific heat of water times positive 45. Close bracket, that whole side times MI. So it's a doozy. There's a lot of terms. Gesundheit. Thank you. You're welcome. And now we can just start solving and compressing things down. As soon as I remember where my calculator went. Oh, dang, I did it again. I'm sorry, guys, I was making some sign mistakes the entire time. That one's on me. Basically, everything on the left side should have already been negative because we are removing thermal energy, so that makes the most logical sense. So, sorry, the cooling the steam down term should be 100 minus 115 because we are going down in temperature. So this means this should be negative 15, and this compressed should be negative 3015. Meanwhile, since we are removing thermal energy to try to condense it from steam into liquid, we have to remove this much thermal energy, so we just have to make the term negative on our own. That should be negative 226,000. This term I had written correctly though, because we are cooling down, we're going to decrease by 55 degrees. That's going to give us negative 23,023. Any objections so far? We're going to wrap this up real quick, and that'll be it for today. Does anyone disagree with the right side?
Is it 3/8 or 2/8 in that last?
You're right, it's 2/8. I don't know why I got carried away. Thank you for catching that.
It
That
is
would've-
objectively the best number to write, so like it's fun. But
It does have symmetry through most axes. I do appreciate that about it. That said, sometimes my, I don't know how I write it that it ends up doing this. Yeah, that's why. Sometimes my 4s and my 9s and my 8s all end up kind of mixed into each other. So it's just a problem for me specifically. But now we can just compress everything on each side down into a single term. And all the negatives on the left are just going to cancel, giving us with a nice 252,038. And then on this side we will have, or on the right side, we will have 533,910 times mass of ice. Put it all together, divide that big number over. What mass of ice do we get?
0.472 kilograms.
Yes, sorry, I put something in my calculator incorrectly. Yes, our final answer should be 0.472 kilograms, which is not a lot. Doesn't take a lot of ice to do this. Ice is a very good heat sink. That is one of the longest questions we're going to be hearing for a while. All wrapped up and out of the way. Thank you all very much. I will see you, at the very least, class next Tuesday. If you've already had lab, if you had lab this week, I'll see you then. If you haven't, I'll see you soon. I'm working on all homework assignments. I'm prepared for chapter 10 questions next Tuesday. And you have a wonderful day and a wonderful weekend.
Beautiful.
Stay safe. Don't play with Alaska.
are they including like violence for animal statistics also? 'Cause I feel like, bear attacks are gonna be higher.